Alright, so this video should mark the close of our brief adventure into radians and angles and the coordinate plane. This is a huge topic in pre-calculus that you'll spend a really long time on, and we're like at the cusp of learning something just really big and new. So that's kind of exciting. I wanted to give you guys a taste of what it was like, but I didn't want to get too in-depth because you're going to learn all about it next year. Anyway though, to close out our little segment here, we're going to talk about how you look at pictures and measure the angles in radians as opposed to degrees we did earlier on in a few videos back. So, worst case scenario, what you could do in problems like this is convert these numbers into degrees, like we did in the last video, then figure out your answer in degrees, and then convert it back into radians at the end. But it seems like that'd be kind of a waste, and it kind of like defeats the purpose of learning a new unit if you're always going to try to avoid it by converting back into degrees. What we really want to do is just deal with it head on when it's in radians. And in order to do this, common denominators are going to be your friends. So when I look at this problem right here, this angle is pi over 6. What I want to do is deal with radians over 6 in this problem. So as you recall, 90 degrees is the same thing as pi over 2 radians. So I multiply the top and bottom, I want to get over 6. Same thing as 3 pi over 6. So when I go to the length of this whole quadrant right here, that's going to be 3 pi over 6 radians. And this quadrant, again, is 90 degrees. Well, if this is pi over 6 of it, that means that this angle right here has to be 2 pi over 6. So altogether, the measure of my angle is going to be 5 pi over 6 radians. The common denominators make it so much easier to do. On my next one here, it's the same sort of idea, but this time I'm going backwards around. Now I have over 5 in the radian they gave me in the problem. That's not ideal because I want to do go by 90 degree increments, and that's pi over 2. So what I'm actually going to do is make this even, multiply top and bottom. This angle is the same thing as 4 pi over 10. So I'm going to make all my problems here over 10, all my radians to count it out. So what I'm going to have, 90 degrees is the same thing as 5 pi over 10 radians. So I'm going in the negative direction. So I have negative 5 pi over 10 radians, negative 5 pi over 10 radians, negative 5 pi over 10 radians. And then I have that negative 2 pi, that's just this part right here, negative 2 pi over, negative 4 pi over 10 radians. So if I total all of those things together, it appears I'm looking at negative 19 pi over 10 radians. So if you convert them into just common denominators, it makes the problem very manageable.